When you multiply something like x plus 1 times x plus 2, we basically do what's called a distributive property, where we do x plus 1 times x and x plus 1 times 2. And then we do the distributive property again to get x times x plus 1 times x plus 2 times x plus 2 times 1. What ends up happening, really, is that there ends up being 4 multiplications. The first get multiplied together, the outers, the inners, and the last. And that's sometimes known in this country as FOIL. Well, if I have x plus 1 times x plus 2 times x plus 3, I could get the answer in this kind of unusual way where, rather than in FOIL, something from the first parentheses gets combined with something from the second parentheses, and all 4 ways of doing it happen. Well, here I have 3 sets of parentheses, 2 things in the first, 2 things in the second, 2 things in the third. So I can create a term by, for instance, taking the x from the first, the x from the second, the x from the third, to get x to the third. And then I can get another expression by using the x in the first, the x in the second, but the 3 in the third. I'll say plus 3x squared. Or I could use the x from, I'll use the third color, the x from the first, the 2 from the second, and the x from the third, which would become 2x squared. Or I could use the 1, the x, and the x. Well, those things all come together to become 6x squared. And I can do the same thing. Oops. With the x terms. I could use a 1 with a 2 and an x, which would be 2x. Or I could use the x with the 2 and the 3 to get 6x. Or I could use the 1, the x, and the 3 to get 3x. And it ends up together becoming 11x. And finally, that's actually taken care of. 1, 2, 3, 4, 5, 6, 7. There's 8 terms altogether. It's 2 times 2 times 2. And the last one is just using the numbers, the 1, the 2, and the 3. If I make a term out of that, I get 1 times 2 times 3, which is 6. So this may seem like a pretty lengthy way to do this question, but it's going to come in handy as we analyze something like x plus 1 to the 5th power. And let's say I don't want the whole thing. I just want to know the x to the 3rd term. Because this thing, x plus 1, 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 that's going to have 32 terms before I start combining them. But most of them are not going to be x to the 3rd. Like one of them that will is xxx, 1, 1, that's x to the 3rd. Or x1, x1, that's also x to the 3rd. Each of these individually, xx, x1, 1, is the same thing as 1, x to the 3rd. X, use the 1 from the second. X, x1, that's also 1, x to the 3rd. So the real question is, how many of these will there be? Since they're all 1x to the 3rd, 1x to the 3rd, that's going to end up being our answer, the number of things on this list. Well, the number of things on that list is 10, because 5c3 is 10, or 5c2 is 10, because this word, if you want to call it that, has 5 letters, and 2 of them are 1s, and 3 of them are x's. So the answer is 10x to the 3rd. In general, if I have x plus 1 to the n power, the x to the r power, its coefficient is going to be NCR. So if I say x plus 1 to the 10th power, and I want to know the x squared term, is going to be 10c2 x squared. Which is 45x squared. What if it's not x plus 1? What if it's more complicated? Like a plus b squared, or a plus b to the third? Well, we can see what happens here. It's sort of the same trick. If I were to write out a plus b all these times, there would be a certain number of a to the thirds using all three a's, all three things being a's. Or there are some that have two a's and a b, or some that have an a and two b's, or some that have three b's. And each of these, if I create a term like AAB, that's going to be sort of three letters, two of them are a's, and that's why the numbers in front of these terms are going to be 3C3. This is going to be 3C2, going to be 3C1, going to be 3C3. Now those numbers, if they're small enough, if this number here is small enough, we can actually make a little Pascal's triangle to get the four coefficients. So it's going to be 1a to the third plus 3a squared b plus 3ab squared plus 1b cubed. When you do that, it's called binomial expansion, when you're raising something to a power. So a plus b to the n power. If you want to get real fancy, you can say sum as n equals 0. Sorry, as I equals 0 to n. NC, when it starts off, it's NCN, so I'll say n minus I. And then here we have a to the n minus I power and b to the I. This is really too fancy for what we're trying to learn. Imagine it was 2x plus 3 to the, I think to the 5th power. Let me check. To the 4th power. We go like this. That's a and b. So it starts off with to the 4th power. Leave a little room for the exponent, sorry, for the coefficient. See, the exponents go down on the a term and up on the b term. They always add up to 4. And the coefficients are 4C4, 4C3, 4C2, 4C1, 4C0. Which from Pascal's triangle, if I want to go 1, 4, 6, 4, 1 is the next row. And then we can put these all together. When we combine like terms, we end up with 16 x to the 4th plus 96 x cubed plus 216 x squared plus 216 x plus 81. If this is negative, if the b is negative, this is going to start off as 5c5, 3x to the 5th, negative 2 to the 0, which is just the same thing as 243x to the 5th. The second term is going to be 5c4, which is equal to 5 times 3x to the 4th times negative 2 to the 1st, and when you combine that together, you get minus 810x to the 4th. And just so you know, you can continue it yourself. 1080x to the 3rd minus 720x squared plus 240x minus 32. Now sometimes they ask only for a specific term, like what's to the x to the 6th term of 2x, hold on a sec, minus 3 to the 10th. So every term is going to have this structure. In this case, 2x to some power and negative 3 to some power. Now, since I want to get x to the 6, I need to put a 6 right here. And these two numbers have to add up to 10, so I'll put a 4 there, and a 10 here. And you could choose, you could either put the 6 or the 4. I like to put the 6 here. So now I can look up, well, on the calculator, I could do 10c6, which is 210. 2 to the 6th power, see, that's why I need my parentheses, is 64. And negative 3 to the 4th, that's why I need my parentheses, otherwise I'll have negative, is going to be positive 81. X to the 6th. And those things all become 1,088,640 x to the 6th. So that's how you do binomial expansion. And that is that.